Good morning, all of you. This is my fifth lecture on engineering mechanics subject. In this session, I'm going to explain about parallelogram law of forces, triangle law of forces, polygon law of forces, and method of projections. Okay, in this session, I will explain about these four topics. Okay, and also I will explain three problems on method of projections. It is very useful for engineering mechanics starting beginners. For finding the resultant of a system of concurrent coplanar forces acting on a rigid body, we use four methods. First one is parallelogram law of forces, and second one is the triangle law of forces. Third one is the polygon law of forces, and the fourth one is method of projections. These four methods are useful to determine the resultant force. Okay, here we can observe these four methods are useful for coplanar forces. Okay, concurrent coplanar forces. Concurrent coplanar forces. First of all, what is coplanar forces? The line of action of all the forces lies in single plane, then the force system is called coplanar forces. Okay, when the line of action of all the forces lies in single plane. Okay, lies in single plane. It's called coplanar system of forces. Okay, concurrent means all the forces meet together at a common point. Okay, for determining the resultant of concurrent coplanar forces, we are using these four methods. First method is parallelogram law of forces. Parallelogram law of forces is useful to determine the resultant of two forces. Okay, in parallelogram law of forces, we are using two forces. Okay, in this method we have both graphical and analytical solutions. We can determine the graphical solution and analytical solution by using parallelogram law. Okay, parallelogram law of forces is used to determine the resultant of two forces only. Okay, it is useful for determining the resultant of two forces. Okay, similarly, triangle law of forces also useful to determine the resultant of the two forces. Okay, triangle law of forces also having both graphical and analytical solutions. Okay, we can determine the solution by using graphical method or analytical method. Polygon law of forces. In this method, we can determine the resultant of n number of forces. Okay, you can determine the resultant for n number of forces. Okay, that means two or more forces. Okay, for polygon law of forces, we have only graphical method. Okay, by using graphical method, we have to determine the resultant of the we have to determine the magnitude of the resultant. Okay, and fourth method is method of projections. And this method also useful to determine the resultant for n number of forces. That means two or more forces. You can determine the resultant for two or more forces. Okay. In this method, only we have analytical solution. There is no graphical solution. Okay. So these four methods are useful to determine the resultant for concurrent coplanar forces. Okay. Concurrent coplanar forces. First one is a parallelogram law of forces. It is very important for subject point of view and also exam point of view. It is very important. This is the statement for parallelogram law of forces. It states that parallelogram law of forces statement. It states that if two coplanar concurrent forces acting at a point are represented in magnitude and direction by two adjacent sides of a parallelogram, then the diagonal passing through the point of intersection represents the resultant in both magnitude and direction. Okay, from this statement, we can determine the resultant for two forces. Okay, here I am considering two forces, that is force P and Q. Okay, P is the horizontal force. Okay, the magnitude of this horizontal force is P, and another force makes an angle alpha with respect to the first force. Okay, so alpha is the angle between two forces, and Q is the magnitude of the second force. Okay, now we have to determine the resultant for these two forces. For determining the resultant for these two forces, first you have to draw a parallelogram. Okay, this is the parallelogram. Okay, by using parallelogram, you can determine the resultant. Okay, this is the diagonal for the parallelogram. Okay, the length of this parallelogram represents the magnitude of resultant. Okay, this diagonal line indicates the resultant, direction of resultant. Okay, from this statement, first, if two coplanar concurrent forces, two coplanar concurrent, coplanar means all the line of action of all the forces lies in single plane and meet together. Okay, two coplanar concurrent forces acting at a point, at a common point, are represented in magnitude P and Q and direction by two adjacent sides, like this. Okay, here the length of this dotted line is equal to the length of the force P. Okay, the length of this inclined line also equal to the length of the force Q. Okay, now it is a parallelogram. Okay, now alpha is the angle between the two forces. Always the resultant passing through the corner. So this diagonal line indicates the resultant, direction of resultant. Okay, the magnitude of resultant is equal to the length of the resultant. Okay, this is the graphical solution. For determining the magnitude of resultant, you have to measure the length of the diagonal line. Okay, so from this method, you can determine resultant force from graphical solution. Okay, Now, by using these formulas, these are the analytical formulas. By using these analytical formulas, you can find the resultant directly. Okay, there is no need to draw the diagram. Okay, by using these formulas, you can determine the magnitude of resultant and direction of the resultant. Okay, here theta is the direction of the resultant. Okay, here the angle theta represents the direction of resultant. Okay, now you can observe magnitude of the resultant. The formula is capital R. Capital R means resultant. Capital R equal to square root of horizontal force square plus inclined force q square plus 2pq cos alpha. Okay, this is the length of the resultant. Okay, here tan theta is the direction of the resultant. Okay, for determining the angle theta equal to tan inverse of q sin alpha by p plus q cos alpha. Okay, alpha is the angle between two forces. Theta is the angle between the resultant and first force. Okay, these three are the graphical solutions. These two formulas are analytical solutions. Okay, and second method is a triangle law of forces. This is the statement for a triangle law of forces. It states that if two coplanar concurrent forces acting simultaneously on a particle be represented in magnitude and direction by the two sides of the triangle taken in order, their resultant may be represented in magnitude and direction by the third side of the triangle taken in opposite order. Okay, so this triangle law of forces method is used to find out the resultant of two coplanar concurrent forces only. Okay, from this statement, here force P and Q are the two concurrent coplanar forces. Okay, these two forces are lies in single plane and meet at a common point. Okay, the angle between these two forces is alpha. Okay, alpha is the angle between these two forces. Here, from triangle law of forces, we have to find out the value of resultant. Okay, for determining the magnitude of resultant, you have to draw a force P like this. Okay, here I am taking first force as it is. Then after, you have to take second force here. Okay, you have to move this force from this corner to this corner like this. Okay, here you can observe the angle between angle between force Q and horizontal plane is alpha. Okay, same angle. Okay, here you can observe I am drawing a line. Okay, I am joining a force P and Q like this by using a dotted line. This dotted line indicates the force resultant force. Okay, this dotted line indicates magnitude of a resultant. Okay, by taking suitable scale, you can determine the magnitude of a resultant. Okay, and also you can find out the direction of a resultant. That is theta. Okay, theta is the direction of a resultant force. This is the graphical solution. Okay, this is the graphical solution for triangle law of forces. For determine the resultant of the two forces, you have to draw a triangle like this. Okay, this method is useful for determining the resultant of two forces only. Okay, for two forces. And third method is Polygon Law of Forces. This is the statement for Polygon Law of Forces. This method is useful to determine the resultant force for n number of forces. That means more than two forces. You can determine the resultant for more than two forces. Okay. For example, if three forces are acting like this, P, Q, S are the three forces. How to determine the resultant for these three forces? From this statement, if a number of coplanar concurrent forces acting on a body such that they represented in magnitude and direction by the sides of a polygon taken in an order, the resultant is represented in both magnitude and direction by the closing side of the polygon taken in opposite order. Okay, so this Polygon Law of Forces is used to find out the resultant of more than two coplanar congruent forces. Okay, so here I am taking this horizontal force. Okay, by taking suitable scale, okay, you can determine the magnitude of resultant. Okay, here I am taking a suitable length for the force P. Okay, I am taking the direction as it is. Then after, you have to draw a second force. You can take any force. Okay, here I am taking a Q, force Q. Okay, so you can observe again. Okay, so here this second force Q makes an angle theta with respect to the horizontal. And now I am taking this force S here. Okay. Now, by closing these two corners, you can get the value of resultant. Okay, this closing side indicates the magnitude of resultant. Okay, this closing side indicates magnitude of a resultant. Okay, R is the resultant. Okay, so Polygon Law of Forces, this method is useful to determine the resultant for more number of forces, for n number of forces. Okay, this is only graphical solution. Okay, this is only graphical solution. There is no analytical solution. Okay. Polygon Law of Forces is a graphical method. Okay, is a graphical method, not a analytical method. And last method is a method of projections. Okay, it is an analytical method for defining the resultant of two or more coplanar concurrent forces. Okay, so method of projections is a analytical method. Is a analytical method for determining the magnitude of a resultant for n number of forces. N number of forces means more than two forces. Okay. So here you can observe Here I am taking four forces. F1, F2, F3, F4 are the four forces acting at a common point. Okay. Now we have to determine the magnitude of a resultant for these four forces. First step, first you have to resolve the forces. First you have to resolve the forces F1, F2, F3, F4 along the x-axis and y-axis. In previous class already we explained. Okay, in yesterday class already I explained how to resolve the forces into x component and y component. Okay, so please refer yesterday class. Okay, in first step, first you have to resolve the forces, resolve all the forces into x component and y component. Okay, and the second step is find sum of all the forces along x-axis. Okay, sum of all the forces along x-axis. That means the sum of all horizontal forces. Summation fx. Summation fx means sum of all horizontal forces. Okay. Then after you have to find out the summation of all the vertical forces. That is summation fy. Summation fy means sum of all vertical forces along the y-axis. Okay. After that, by using analytical formula, resultant or equal to square root of sum of all horizontal forces square plus sum of all vertical forces square. Okay, this is the formula for magnitude of a resultant. Okay. This formula is very important. Okay, for determining the resultant for two forces. Okay. Here you can observe. Here I converted these four forces into horizontal force and vertical force. Rx equal to sum of all horizontal forces. Ry means sum of all vertical forces. Okay, I converted these four forces into two forces, x and y force. After that, you have to convert these two forces into single force. That single force is called resultant. Okay. For determining the magnitude of resultant, or we have to use formula R equal to square root of horizontal forces square plus vertical forces square. Okay. After that, if you want to determine the direction of the resultant, then you have to use another formula, that is tan theta x equal to f y by fx. Sum of all vertical forces divided by sum of all horizontal forces. Okay. So here theta x represents the direction of a resultant. Theta x equal to tan inverse of summation of vertical forces divided by summation of horizontal forces. Okay. So this formula is useful to determine the direction of a resultant with respect to the x-axis. Okay. Direction of a resultant with respect to the x-axis. Theta x means direction of the resultant with respect to the x-axis. Okay. Now I am going to explain some problems, simple problems on method of projections. Okay, this is a given diagram. Here, three forces are acting at a common point. That means these three forces are lies in single plane and making and meet at a common point. Okay, here you can observe 70 newtons force lies on x-axis, 60 newtons force lies on y-axis. Okay, and this 100 newtons force lies in first quadrant. Okay, and makes an angle 30 degrees with the x-axis. First of all, you have to convert these three forces into horizontal forces and vertical forces. Okay, Now I am taking the x-axis and y-axis for converting the forces along the x and y-axis. Okay. Now I am drawing the x component. That is, I am taking a 70 newtons force as this. Now you have to consider this 16 newtons force as this, like this. Okay, here there is no need to convert these two forces because these two forces lies on x-axis and y-axis. Okay, now this 100 newtons force lies in first quadrant. Okay, this 100 newtons force lies in first quadrant like this. Okay, here the force F equal to 100 newtons. Okay, first you have to resolve this. First you have to resolve this 100 newton force into horizontal force and vertical force. Okay, here the force F makes an angle theta with respect to the x-axis. Okay, that's why this one is adjacent side. Okay, this one is adjacent side, this one is opposite side. Okay, for adjacent sides you have to consider cos theta. For opposite sides you have to consider sin theta. Okay, here the force F moves towards right. Okay, so you have to consider positive sign. Okay, this is the x component. So here I am drawing this F cos theta like this. Okay, now you have to draw this vertical force like this. Okay, now you can observe I converted these three forces into horizontal and vertical forces. Okay, so these are the sign conversions for determining the resultant. Okay, for right side direction you have to consider positive sign. For left side direction you have to consider negative sign. For upward direction you have to consider positive sign. For downward direction you have to consider negative sign. Okay, now you have to add or subtract forces. First I am taking forces. Okay, 17 newton force, 16 newton force, 100 newton force, and angle 17 newton force lies on x-axis. That's why I'm taking 0 angle. 16 newton force lies on y-axis, so I am taking 0 angle. And this 100 newton force makes an angle theta, that is 30 degrees with the x-axis. Okay, now you can observe from this figure, we have to identify the horizontal forces for x component. 17 newton force lies on x-axis, that means x component. This is a x component. Okay, x component always lies on x-axis. Y component always lies on y-axis. Okay, so 17 newton force, the magnitude of this 17 newton force equal to minus 70. Okay, for left side direction you can observe here, from left side direction you have to consider negative sign. Okay, okay, this 17 newton force lies on x-axis, that's why the y component is 0. Okay, now I am considering 16 newton force. This 16 newton force lies on y-axis, that's why it has only y component, that is minus 60. Minus sign indicates downward direction. You can observe here downward direction. For downward direction you have to consider negative sign. Okay, okay, this force lies on y-axis, that's why the x component is 0. Okay, now 100 sin 30, 100 cos 30, these two are the forces for 100 newtons. Okay, so this 100 cos 30 lies on x-axis, that's why it is a x component. and this 100 sine 30 lies on y-axis. So you have to treat this force as a y component. Now x component equal to 100 cos 30. Positive sign indicates right side direction. Okay, right side direction. And this one is a y component plus 100 sine 30. Here positive sign indicates upward direction. Okay. Now you have to add all these x components. There is a sum of all horizontal forces equal to fx. Fx means sum of all horizontal forces along the x-axis. Sum of all horizontal forces along the x-axis equal to 16.60 newtons. Okay. By adding these three forces, you can get the value of summation fx. Now, by adding these three y components, you can get the value of summation fy. Summation fy means sum of all vertical forces along the y-axis. Okay. From the formula for projection method of projections, resultant R equal to square root of horizontal forces square plus vertical forces square. Okay. By substituting these two values in this equation, you can get the value of resultant. This is the magnitude of a resultant. 19.38 newtons is the magnitude of a resultant. Okay. And this is the direction of a resultant. Direction, for determining the direction of a resultant, theta equal to tan inverse of vertical forces square divided by horizontal forces square. Okay. From this equation, you can get the value of direction theta equal to minus 31.06 degrees. Okay. Now I want to represent a resultant. Here, fx, fy. First, you have to identify the sign conversions. Here, fy is negative sign. That means force, sum of all vertical forces, summation fy, taking downward direction for negative sign, and summation fx, sum of all horizontal forces equal to plus 16.60. Positive sign means you have to consider a force in right side direction. Okay, this is the position of a resultant. Okay, this is the position. Okay, resultant lies in fourth quadrant. Okay, because here the x-axis value is positive and y-axis value is negative. Okay, that's why the resultant always lies in fourth quadrant for this problem. And the angle of this resultant is theta x. Theta x equal to minus 31.06 degrees. Minus sign indicates clockwise direction. Okay. So this is the position of a resultant. Okay. This is a single force. Okay. Coming to another example. Yeah. This is a horizontal force. This is a vertical force. No need to convert these two forces. Now you have to convert this inclined force 100 newtons into two forces. That is the x component and one y component. This force lies in second quadrant. So you have to consider second quadrant equation. Okay. So here the angle is theta with respect to the y-axis. So this y-axis is adjacent side and this x-axis is opposite side. For opposite sides, you have to consider sin theta. For adjacent sides, you have to consider cos theta. From this equation, you have to draw the x component and y component. Okay. Now, here these two are the x components. These two are the y components. Okay, these are the sign conversions. These are the forces, given forces. These are the angles. Now these two are the x components. So just you have to write down like this. Okay. Here 100 sine 40 and 70. These two are the x components. So 70, 100 sine 40. These two are the x components. Positive sign means towards right. Negative sign means towards left. Okay. For left side direction, you have to consider negative sign. For right side direction, you have to consider positive sign. Okay. Now these two are the vertical forces. That means y components. Upward direction. For upward direction, you have to consider positive sign. For downward direction, you have to consider negative sign. Okay. Plus 100 cos 40 minus 60. Okay. These two are the y components. So by adding these three forces, you can get the value of summation fx. Okay. By adding these three vertical components, you can get the value of summation fy. Okay. These two are the horizontal and vertical forces. Now you have to convert these two forces into single force. That means resultant. Resultant is the single force. Resultant equal to square root of horizontal forces square plus vertical forces square. Okay. And the magnitude of a resultant equal to 11.52 newtons. And the direction of a resultant equal to minus 60.23 degrees. Now from these values, you have to identify the location of a resultant. Okay. Fy, the sign of fy is negative. Fy means vertical axis, downward direction, and x-axis is positive. So like this. So here the resultant force lies in fourth quadrant. Again, like this. This is the position of a resultant. This is the magnitude of a resultant, and theta x is the direction. Okay, direction of a resultant with respect to the x-axis. Okay, theta x is the direction of a resultant with respect to the x-axis. So this is the final position of the resultant. Now coming to the last model, last problem. Here from this given figure, okay, you have to convert all these three forces into x component and y components. Okay, so here I am taking this vertical force as it is. Now then after you have to convert this 70 newtons force into two forces. This 100 newtons also you have to convert. Here this 70 newtons force lies in second quadrant like this. You have to convert this 70 newtons force into x component and y component. Okay, here minus f sin theta is the x component plus f cos theta is the y component. Okay, this is the adjacent side, this is the opposite side. 70 sin 40, that means minus f sin theta. Okay, this is the y component, that is f cos theta, 70 cos 40. Okay, now I am drawing this 15 newton force as this. Okay, now I am converting this 100 newton force into two forces, that is the x-axis and y-axis. This 100 newton force lies in first quadrant. So from this equation, you have to identify the x component and y component. This is the x component, this is the y component. Okay, this is the angle. Here angle theta equal to 30 degrees and force F equal to 100 newtons. Okay, so this is the x component. So I am drawing the x component like this, 100 cos 30. Okay, now this is the y component. I am drawing this vertical force on y-axis like this. Okay, so here you can observe 70 sin 40, 100 cos 30. These two are the horizontal forces. That means x components. These two are the x components. Now 15 newtons, 70 cos 40, 100 sin 30. These three are the vertical forces. That means y components. These three are y components. Okay. These are the forces, given forces 70, 50, 100. Now angles, these are the angles. Okay. 70 degrees, 70 newtons force makes an angle 40 degrees with respect to y-axis, and 15 newtons force lies on y-axis, that's why 0 degrees, and 100 newton force makes an angle theta, makes an angle 30 degrees with respect to x-axis. Okay, now we have to note down these two horizontal forces. Okay, these two are the horizontal forces, these three are the vertical forces. Okay, for signs, you have to consider these sign conversions. For left side direction, you have to consider positive sign. For left side direction, you have to consider negative sign. For vertical direction, positive sign. For downward direction, negative sign. Okay, by using these conversions, you have to identify the directions. Okay, summation. By adding these three horizontal forces, you can get the value of summation of x. By adding these three vertical forces, you can get the value of summation fy. Okay, now this is the formula for resultant. Magnitude of a resultant R equal to 67.87, 67.87 newtons. This is the magnitude of a resultant, and this is the direction of a resultant. Here you can observe the value of fx is positive, and the value of fy is also positive. That means the resultant lies in first quadrant. X-axis is positive and y-axis also positive. Okay, these two are positive side. That means the resultant lies in first quadrant. Okay, like this. Okay, the angle of resultant is theta x. Theta x is the direction of a resultant with respect to x-axis. The angle is 51.19 degrees. Okay, this is the final answer for this problem. Okay. Okay, these are the example problems for determining the resultant force by using method of projections. Okay, in next class, I will explain how to determine the resultant for different applications. Okay, thank you.